Good morning everyone, I'm Lorenzo Stacchion and I'm here to present to you our novel work called AnnHoloTator, a mixed reality collaborative platform for manufacturing work instruction interaction. This work was done along with Vincenzo Armandi and the professors Lorenzo Donatiello and Gustavo Marfia. So, the outline for this presentation will be the introduction and motivations. We will have a comparison with related works. I will try to explain to you what are the main differences between our platform and existing ones for the reference use case. I will provide you an overview of all the AnnHoloTator features and the main components, and of course at the end of this presentation I will show to you a step-by-step explanation of how the system works with a live demo. So, we know that extended reality technologies may play a key role in the digital transformation sparked by the Industry 4.0 initiative. Despite this, a lot of works focused on the integration of just artificial intelligence, IoT, and cloud computing technologies, often lacking the integration of extended reality one. Augmented and mixed reality may emerge as disruptive technologies, as proven by the increasing body of research in the industrial augmented reality field. Industrial augmented reality could be put to good use to empower industrial workers in their everyday activities. Indeed, DR plays a core role in lean manufacturing processes because it can maximize worker efficiency and mobility by providing virtual elements in real-world scenarios where and when necessary. As reported in 6, the few lean manufacturing and industrial augmented reality application focus on providing work instructions in the ideal format and space in a situated visualization setting to create an uninterrupted workflow while allowing user hands to be free. We also follow this philosophy, but with a completely novel approach. So, collaborating with an electrotechnical company, we performed an analysis of the everyday activities of professional workers there from a lean manufacturing perspective. We found out that electrical board assembly could be optimized using ER paradigms. In particular, the EBA consists of 3 main steps: visualizing electrical circuit connection schemes, working on the physical electrical board to make the electrical connections, and annotating information related to the current activity on the visualized documents. These steps basically creates a loop where a user continuously moves physically between the electrical board and a workstation for examining some information in the digital documents. This result in a loss of time and focus, which also reduces the quality of the work done by the professional workers. Considering this, we decided to inject mixed reality paradigms, in this case, into this loop, to let the user focus on its work, while keep visualizing and modifying information exploiting a mixed reality headset. In our case, the HoloLens 2. This allows workers to avoid going to a workstation or flip the pages of a paper manual, thus decreasing the time needed to perform a task along with the error rate. Analyzing the works closest to ours, we found a lack of products that provides together the following features: situated visualization of digital documents, an annotation system to annotate the virtual counterparts of digital documents, a collaborative mechanism or collaborative mechanisms, and a data-oriented approach. We provided a system that could put holistically all of these features. We named our system AnnHoloTator, and the main features provided by AnnHoloTator are a way to explore and interact with the holographic versions of digital documents in the physical environment, providing in-file searching methods. Moreover, it also includes an annotation system to annotate documents directly in mixed reality. In AnnHoloTator, the HoloLens 2 application acts as a visual and manipulate tool. A remote server stores and performs the bulk of needed computation. And the main advantage of this is that we wouldn't waste any kind of memory or CPU resource in the HoloLens 2. Moreover, this brings another advantage to the system. The annotation system works asynchronously. In practice, an on-site professional can write on the hologram, so the virtual document in our case, whenever he wants, and then share the annotated document and the annotation takes on it with others by simply storing them in the remote server. That provides inherently a collaborative aspect, because of course people that wears the HoloLens and had access to the same database can visualize the annotations taken from other workers. So the main features provided by AnnHoloTator are three, and are the file system browsing, the visualization mode, and the annotation mode of digital documents. In the file system browsing mode, the user can choose the remote servers to connect to, browse its file system. So for example, he could pick a known IP address, and he could access all the files provided by the server hosted at that particular IP address. This type of access provides a distributed approach for users. And this means that each worker can access only a specific set of servers, and to guarantee the data security, and this provides a simple way to implement this aspect. Once a user correctly accesses a reference server, the system spawns a file system explorer that can be explored graphically. In this work, we considered only PDF documents, here processed as a set of images, as sets of images. But of course, this approach can be generalized to any kind of document. Once the user has explored the file system and have decided to pick one particular PDF file, it enters in the visualization mode. In this mode, a user can navigate through the pages of a document by clicking basically on the side buttons, previous and next page, or using the respective vocal commands. It could also manipulate the document hologram, modifying its location and size. And this mode provides also two advanced file browsing modes, the key and the page search one. In the page search mode, the user can select the page of the document you want to visualize from a drop list on the side of the document's hologram. In the key search mode, the user can search the pages where certain keywords occur. For keywords, we intend a specific technical word that appears in the original document, which are tracked by the remote server. The keyword can be input with a virtual keyboard, and the system will provide all the pages in which that particular keyword appears, along with its bounding box. So, the annotation mode allows the user to directly annotate a particular page of a document's hologram in mixed reality by using an interaction. Various kinds of annotation could be inserted within a document, allowing one to enter information that may be proved to be useful in the future. This is the component meant to support asynchronous collaboration, in which each user may contribute with annotations. The first sub-mode provided by the annotation mode is the drawing one. In the drawing mode, a user can take freehand written notes on the current page of the document. This type of annotation provides a high level of flexibility for the user, since it can add notes, underline text, highlight sections, and even draw some symbols. Finally, the user could set the color of the annotation along with its size. The check mode feature allows users to add affirmative annotation within the document by simply tapping with their finger where they want to insert the annotation. And the same happens with the uncheck mode, where instead a negative annotation will be placed. The text mode is the last one, and provides a simple but yet useful method to take some textual notes on the document. In practice, the user, by finger tapping, could choose the location where he wants to put the textual annotation, and the system will spawn a virtual keyboard. And of course, the user could write whatever text he wants. And once the enter button is pressed by the user, a textual graphical field will be overlaid in the virtual document. And after the insertion, the user can move the text note to a different location. So the system offers its users the classical functionality that will be provided in any kind of document editing software. So an annotation can be, of course, saved, undone, redone, or a user may also decide to reset the document to its original state. So as we told, the documents are interpreted here as images, and also all the annotations, which will be spawned as 3D objects in the mixed reality setting, will be interpreted again as images. And this directly impacts on the save mechanism of the annotation system, because the system practically takes a screenshot of the document along with the annotation posed over the document itself by exploiting the layering and render texture mechanisms provided by Unity. And the server will process, with a classical image processing pipeline, the screenshot provided by the client to store an image which not downgrade the original document quality. In practice, the system isolate and enhance an annotation masked version of the image and overlays it in the original one. In this way, we can maintain the original quality of the document while also providing a way to save these graphical annotations. Now we'll provide a video demo of our system. So the user is able to choose the remote IP address. So the user at this point could explore the file system spawned by our system, and of course he can in a classical setting, so he knows the actual folder path. He'll see all the folders within the actual subfolder, and at a certain point he picked the PDF file of his interest. In this case, the system will spawn what we call a slate. So this container that will show you the image of the current page of the document. All the slates and also the file system explorer can be manipulated in their size and location. And initial mode for the document is the visualization mode. And a user could search for a particular keyword. In this case, for example, the user would search for the keyword cheer. So this means that we will visualize all the words in the document that contains the keyword cheer. And in this case, the keyword circuit appears in page 0 because these example documents contain just one image. And it can visualize the bounding boxes where the words occurred. You could also browse for all the pages in the document. In this case, the document, as I told you, is just one image. It's just one page. So of course, it can browse only with that. Then notes mode, and we'll start with the drawing mode. So with the hand tracking provided by the MRTK, the user could, as I told you, select the size and the color of the annotation. In this case, we want to do a huge annotation, and by just intersecting the finger of the user hands within the hologram of the document, a lot of 3D objects will be spawned in our slate and will be overlaid in the document to mimic the behavior of a classical annotation system. As I told you, a user could do, for example, the undo of operation, or also the updo or the reset one. So we could, in this case, we just erase some of the last annotations we take, and then we provide another annotation because maybe we were wrong and we picked the wrong color, just as in this example. Now we can proceed to the check mode. And I told you that in this mode we can just select one point in the image to put those checks. Same stuff for the uncheck mode, but in a negative perspective. And finally, we will provide the text mode example. So the user take a textual annotation. It could type whenever he wants. In this case, we will type note, and of course we placed in the starting point intersection point, but we can move it whenever we want. Now the user could, of course, save the annotation. This will trigger all the image pipeline from the robot server that we talked about before. And after the save, this image is not composed by holograms anymore, but this is the real image, so the real 2D representation of the image, which is stored also in the server, which is then, of course, represented in the virtual document. And that's end our demo. So, in our work, we introduce AnnHoloTator, a mixed reality system for the HoloLens 2 that allows users to visualize, manipulate, and annotate the 3D version of digital documents. It also provides a way to do in-file searching methods and supports a data-flexible and collaborative approaches while avoid overloading the HoloLens 2 computational capabilities. To verify its effectiveness, we will carry out a user testing in a target industrial context. We also plan to extend AnnHoloTator, including novel client features and deep learning OCRs to speed up search mechanisms. These are all the references I use in this presentation that follow the paper indexing to avoid confusion. To conclude my presentation, I will show to you a short video of professional workers which are trying AnnHoloTator in an industrial context. And I thank you for your attention, and I am here for any kind of question you have. on AnnHoloTator.